Hi friends. Now let's start with the next question of practice set 1.1. That is your question number third. Question number third we are going to do it over there. Question number third. It's a very easy, very simple sum. Let's read out the sum first. Wrote the question over here. In the adjoining figure 1.14, which is the number of your textbook, the figure number is there, and then they have given that sec PS is perpendicular to sec QR. Sec PS is perpendicular to sec QR. Can you see that over there? Then sec QT perpendicular to PR. QT perpendicular to PR. They are given RQ6. Where is RQ6? PS6. PS6. And PR ka value they have given it what? 12. And they told to find the value of QT. They told to find the value of QT. Now to find the value of QT, it's very simple, very easy. We will be having a two triangles first. We'll be seeing these two triangles in this figure. Now first of all, I'll draw a separate triangles for you all over there. First, I will draw for you all over here. I'll be doing over here. I'll be drawing it. You will be having one. The triangle ka name is RQP. Can I have a triangle as RQP? Yes. Now RQP, if you check this out over there, that in this triangle they have given the, if you check this out over there, that this is RQ ka value is 6 and there is a perpendicular height which has been drawn over here is PS and that has been given 6. So I'll be first going out in the sum over there. I'll be writing over here in triangle PRQ. PRQ, can I go for this over here? PRQ. There you can see that over there. Can I apply the area of a triangle? Now area of a triangle PRQ, I'll be getting what over here? That half, you know the formula of area of a triangle, that is your half base. Now here in this case, can you tell me that, they see the diagram from here, I just draw that diagram. I have not written that QT. I have drawn the triangle, I have taken triangle PRQ and PS, where QR is the base. Can I have over here QR is the base and your height is what? PS. Can you see that over there? The height is PS. Can I have a height PS? That is your area of a triangle PRQ, half into base into height. Now if you check this out, this half into QR ka value is 6 and PS ka value is also 6. 2 1s are 2, 2 3s are 6, 3 6 are 18. So you will be getting 18 square units. That is the area of a triangle PRQ. I got the area of a triangle PRQ. Yes. Now what I am going to do to here? Now I am going to draw again the triangle. Now can I take it out the triangle? Here again I will be having you have a triangle PRQ. But now can I take this QT? This is the value being given as 12. You can see this over there. Yes. Okay. I'll be going again in triangle. Where in triangle, I can go for a area of a triangle. Again, I'll be finding the area of triangle PRQ. Now, area of a triangle PRQ. In the second, this is also area of a triangle PRQ. Here also you will be getting a PRQ. But now I will be taking what over there? The base. If you check this out over there, I will take PR as a base. PR as a base and height will be your QT. QT will be a height. PR as a base and QT will be the height. So you will be having same triangle but different base and height. Okay. Now we have already found out the area of triangle PRQ. Now area of triangle PRQ we have already written, that is your 18 half into PR. PR ka value we already got it over there, that 12 and QT the one which we have to find it out. Okay. So this is the QT the one which you have to. Now what has to be done is nothing but 18. 2 will go and multiply with the 18 and 12 will come and divide. Everybody knows that 2 will go and multiply, 12 will come and divide. So 18 into 2 upon 12. Upon 12. 18 into 2 upon 12. This is equals to what? QT. So here you will be getting 2 1s are 2, 2 6 are 12, 6 1s are 6, 6 3 are 18. So what you got the value of QT? QT is equals to what? 3 units. Can you see that over there? QT is that. Therefore, your answer you have to write it over here. The QT ka is equal to what? 3 units that they told to find out the value of QT. So can you see this over there? I went in the same triangle but different base and height, and then I got the QT. Okay. Okay, let's start with the question number 4 of practice set 1.1. Now, question number 4, if you check this out carefully, that they are given that AP is perpendicular to BC. With you can see AP is perpendicular to BC. And AD and BC are parallel to each other. Can you see that AD, line AD and line BC is parallel to each other. They are told to find the area of triangle, the ratio of area of triangle ABC and BCD. Area of triangle ABC and BCD. Now here I'll do one thing over there. It's these two triangles are bit joined in there today. I'll be drawing one simplified diagram because I'll be drawing these two lines again. These are the what over here is the parallel lines. You have a parallel lines coming up. Now when you have a parallel lines over here, I draw a triangle over here, separate over there. This is your A, B, C. I have drawn, and this is your height where you have over here. In this case, AP is the distance between the two parallel lines. Again, for you people to understand, I'll be drawing one triangle. This is a separate triangle. Again, you have over here is your BC and you have D. So these two triangles I have drawn here for you people are separate triangles. Okay, it is joined in this diagram. I've done it separately. Now, if you check it out that over there, this AD and your BC, you have a BC. These two lines are parallel. These two lines are parallel. Now, you know that over there, the parallel lines or distance between them are always same. Then otherwise, if it is not, if the distance between these parallel lines are not same, that means the lines are not parallel. So here if you check it out, that the distance AP is the distance between the two parallel lines which in the triangle ABC, and that is acting as the height of the triangle ABC. Now here in triangle BCD also, the whatever the AP height, the value of AP height will be also here also will be the same, because these two triangles are lying between the parallel lines. So that means it is understood that the triangles are ABC and triangle BCD having equal heights, because they are lying in the parallel lines. Yes or no? Next part, if you check it out that over there, that area of triangle ABC, you have height AP. What is the base? BC. Area of triangle in that over there, triangle B, your BCD. You can see height whatever AP, so here also AP. But the base of this triangle is also BC. So can you see that over there, in this two triangle, they are having both equal. What is that equal both? Is nothing but your height and also the base. Can you see that over there? The height and base both are equal over here. So let's see about that. We have done one property in the previous, yesterday we have done one property. Do you remember when the base height is equal? So what is the ratio of the triangle? When the base is equal, what is the ratio of the triangle? And when both are equal height and base, what is the ratio of the triangle? Do you remember? If you have seen this previous video, you will understand this over there. So I'll be writing over here, in this case first, that the triangle, you have over here triangle ka name is what? Triangle ABC and triangle, I have over here triangle ABC and triangle BCD lies between the parallel lines between two parallel lines, that is AD parallel to BC. That is AD parallel to BC. Now here, if they are lying between the parallel lines, therefore their heights are equal. Then also you can see this from the diagram. You have also their base is also equal. Bases are also equal. Heights are equal and bases are equal. But we have done yesterday that when the triangle with, what is that over there? if the heights are equal and the bases are equal. So what is that over there? We have studied yesterday that over there the area of both the triangles will be equal. Area of triangle ABC equal to area of triangle ABCD. When both the height and base are equal of a triangle, then you will be having over there that the two areas of the triangles are equal. But they want what? What they want? They want the ratio. So and you have seen also that therefore the ratio. You have here area of triangle ABC upon area of triangle BCD will be equal to what? 1. And that is what you will be getting the answer. The ratio of the area of a triangle ABC upon area of a triangle BCD will be equal to 1. And this is what your answer for the sum. Okay? And so simple sum was this. Okay students, we have finished with the exercise number, practice set number 1.1. Now we are going to start practice set 1.2. Before I start practice set 1.2, you have to learn many more theorems and properties over there. Here again you have every exercise you will be having your theorems and properties over there. Let's start with it. What I have written on the board is the first is called as very familiar in that way, basic proportionality theorem. What is this over there? Basic proportionality theorem. Now what is this basic proportionality theorem? First we'll read out it over there. If a line parallel to a side of a triangle intersect the remaining sides in two distinct points, then the line divides the side in the same proportion. Then the lines divides the side in the same proportion. Now did you read that question over there? Okay, read that theorem over there. Now after that I'll explain you the theorem by the with the diagram over there. Now I have a triangle, for example, I have a triangle ABC. I have a triangle ABC. A and B and C. Okay. Now here they told that if a line parallel to a side of a triangle intersect the remaining two sides, that means here I am drawing one line over here. When I try to draw a line over here, you can see this over there. I have a line which is parallel to one side. Now I have a line PQ which is parallel to one side. They told that if a line parallel to a side of a triangle and intersect the remaining side in two distinct points. So that means this PQ is line parallel to one of the side of a triangle and intersecting the other two sides, which is that AB and AC in two distinct points. Which is the two distinct points? That is your point P and point Q. Can you see that over there? Then the lines divide the side in the same proportion. In this case, what is that over here? You have over here in triangle ABC, you have what over there? We have over here is line PQ is parallel to side BC. Can you see that line PQ is parallel to side BC? That's what they told. If a line parallel to one of the side of a triangle intersect the remaining two sides, then the line divides the sides in the same proportion. What do you mean by proportion? That is your AP upon PB. That you have studied your proportional in your algebra in your 9th standard. A upon B is equal to C upon D. So here in this case the sides are in proportion. So in this case AP upon PB. Can I have over here AP upon PB is equals to, therefore on the other side also AQ upon QC. AQ upon QC. AQ upon QC. Can you see this over there? The basic proportionality theorem says that if a line parallel to one of the sides of a triangle and intersect the other two sides, then that sides are been divided in proportion. That is your AP upon PB is equal to AQ upon QC. AQ upon QC. Yeah, this is about your this is your basic proportionality theorem. Next, it is also there, you have a very simple, that is the converse of basic proportionality theorem. Now what is converse of basic proportionality theorem over there? It's ulta. Now what is that over there? Again, if I have in this triangle over there, they told that over there, if a line divides any two sides, converse means you have the same thing, we have to go ulta coming up over there. The converse of basic proportionality, they say that if the line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That means here what we did over here in the triangle ABC, we have line parallel, then the ratios are equal. But in this case, converse it will tell that AP upon PB is equals to AQ upon QC. If it is ratios are equal, then the lines are parallel. parallel, line PQ parallel to line side BC. Here, the basic proportionality theorem says that if the line is parallel, then the ratios are equal. But the converse says that if the ratios are equal, then the lines are parallel. So if can you see that it is written in your textbook? You have to thorough with this. There are lots of sums are there on the basic proportion theorem and the converse of basic proportion theorem, which you have to apply in this exercise. Now I will, after this I have explained you this theorem. Now I will be doing the sum which are related to this exercise, this theorems over there. Okay. Okay students, now I have explained you all the theorem, both theorems I have explained, that basic proportional theorem and the converse of basic proportional theorem. Now we will do one sum of related to basic proportional theorem and the converse of basic proportional theorem, then you will understand furthermore better. Okay, now let's go to find out the, we will see the sum which is from the problem set 1. It is from problem set 1 and sum number 7. Problem set 1. It's not from the practice set, it is problem set. Remember that, okay? Problem set 1, question number 7. Now let's read out this, okay? You have A, D and C. What do you mean by A? This dash they have written, that is A, D and C are collinear points. A and you have a D and you have a C. They are collinear points. B, E, C. B, E, C. They are also collinear points. They are given sec DE parallel to AB. D parallel to AB. It has been given that D, line D is parallel to AB. And if AD ka value they have given it 5, DC ka value they have given it 3, and BC they have given it what? 6.4 minus X. 6.4, BC ka value is nothing but, the BC is full, that is your 6.4, they have given it over there. And what is that over there? 6.4. BC 6.4 they have given it over there. And then find the value of BE. Find the value of BE. So I have already done this over there for you people over there. What is that? It is there in your diagram in your textbook also. It's nothing but I'll be having first in triangle ABC. I have a triangle ABC. Can you see this over there? Now in the triangle ABC, you have what we are going to do it over here is nothing but let BE, which we are supposed to be find out, BX. What I've done it, I kept it in the diagram BX. So here in this case, BE plus EC, BE plus EC is equals to BC, because B dash, E dash, C, they are the collinear points. So I have written BE plus EC is equals to BE plus EC is equal to BC. B ka value we kept it what? X plus EC is equals to, and BC ka value we have in your question over here, that is your question, and they have given it what? 6.4. So in this case, X will be equal, if I want to find the value of EC, therefore your EC ka value will be over here is nothing but 6.4 minus X. So 6.4 minus X. This is how I got that 6.4 minus X. Here I got BE ka value, I kept it what? X. So EC ka value I got it what? 6.4 minus X. Is that correct? This is how I got it over there. Now, do you know that over here the set DE is parallel to side AB. Set DE parallel to side AB. Can you see that in a triangle ABCD parallel to side AB? And we have done just now that basic proportionality theorem that if a line parallel to one side of a triangle and divide the other two sides in two distinct points, then it's divide the two sides in the proportional. So where you can see that DE is parallel to AB. DE is parallel to AB. So you have to start from where? You can see that over there. You can start from your CE. Can I write it over here? CE upon. You have to start because this line is parallel to this side. So you have to start from here. CE upon EB. Remember this carefully. CE upon EB is equals to CD. Upon DA. CD upon DA. And in the bracket you have to write what? By basic proportionality theorem. By basic proportionality theorem. You have to write it by basic proportionality theorem. We got it over there. You have to write the reason why you from where you got this ratio. Remember that. Very, very important. See the lines are now this line is parallel to this side. So you have to start from where? Top, from C. CE upon EB is equal to CD upon DA. Check the line from which line is parallel. Okay, now CE ka value we got 6.4 minus X upon EB ka value is what? X is equals to CD ka value what is that? 3 and DA ka value we got 5. Now what we are going to do here is nothing but very simple. You have to cross multiply, because when you cross multiply, so 5 into 6.4 minus X is equals to 3X is equals to 3X. Therefore you have to multiply 6.4 into 5. 5 4 are 20, 2 carry, 5 6 are 30, 31, 32, and you have a decimal. So after decimal, so you will be getting over here in this case is 32. Then minus 5x is equals to, you will be getting what? 3x is equals to 3x. Now can I take this as over here is nothing but minus 5x minus 3x on the left hand side, and minus 32 will go on the right hand side. Okay, so therefore you will be getting over here in this case is minus 8x is equals to minus 32. So you will be getting over here, therefore you will be getting what? X is equals to minus 32 upon minus 8. Minus 32 upon minus 8. Minus sign will get cancelled. 8 1s are 8, 8 4s are 32. Therefore you got X is equals to 4. You got a value of X is equals to 4. And what we kept it over here, let in the starting over there, let B ka value be X, and they told to find what over here in the question B, and therefore we got the answer. That answer is nothing but the B is equals to, you will be getting over here is equals to 4 units. B is what? Your 4 units. And this is how I completed your question number 7, which is related to your basic proportionality theorem. Okay. Okay students, now previous sum we have done regarding the basic proportionality theorem. Now we are going to do this sum is regarding your converse of basic proportionality theorem, and that is from the practice set 1.2. Remember that was problem set 1, the question number 7. Now this is your practice set 1.2 ka second question. I'm doing it over there, which is all related to your converse of basic proportion theorem. Now how it will come over there, we are going to see in this way. Now here you can see this in triangle PQR. You have a triangle PQR. PM is equal to 15, PQ is equal to 25, PQ is equal to 25, and PR they have given it what? 20, NR they have given it what? 8. State whether the line NM is parallel to side QR and M is parallel to side QR with your give reason. This is your, you have to give a reason. Previous sum we have given that, we have seen that the lines were parallel, and we have done that ratio. Now here the values have been given, and you are told to prove that the line NM is parallel to side RQ. NM is parallel to RQ. No? You have to show that. Okay. So now how it has been done, it's very simple. I'll show you that today. First of all, I'll be going where in triangle PQR. Can I go in triangle PQR? Where what I'm going to do here, this P and R are what? Collinear points. First I will find the value of Pn and I will find the value of Mq. Okay, so here in this case what I'm going to do, Pn plus Nr, Pn plus Nr is equals to, you will be getting what? Pr, and you have to write it over here, P dash N dash R, P dash N dash R. So here therefore you will be getting what over here in this case is Pn plus NR ka value is what? 8 is equals to what over there? PR ka value is what? 20. Therefore Pn is equals to 20 minus 8. Therefore you will be getting what? Pn is equals to, you will be getting what? 12. So this is the value you got, Pn the value you got 12. 12 you got it with it. Same thing will be going on the other side of that PQ. P, M, Q are the collinear points. So can I write it over here? PM, I can have a PM plus MQ is equals to PQ, where you have P dash M dash Q, P dash M dash Q. Okay, where therefore you have your PM is what? 15 plus MQ ka value we don't know, and this is what over there. In this case, PQ ka value is what? 25. So here in this case you have your, therefore MQ is equals to 25 minus 15. 25 minus 15. Therefore MQ is equals to, you will be getting what? 10. So you got the value of MQ is what? 10. Now what I am going to do, it is very simple. You see that okay, I got the value of Pn, I got the value of Mq. Now what I am going to do today, I am going to check it out the ratio. First of all, Pn upon Pn upon Nr. I got the value of Pn is what, 12, Nr is what, 8. So if I cancel this, 4 2s are 8, 4 3s are 12. So I'll be getting 3 upon 2. And that's my equation number 1. I'll keep my equation number 1. It's very simple. Same way go on the other side over there. Check the ratio of Pm upon Mq. Pm upon Mq. Here Pm ka value is what over here? 15. And Mq ka value is what? 10. Mq ka value is also 10. 5 3s are 15 and 5 2s are 10. So I'm getting here also, you can see the ratio what I'm getting, 2 upon 3 and that 3 upon 2, sorry. Yeah, you got that over there. So you got the ratio Pn upon Nr is equal to 3 upon 2. Pm upon Mq also ratio is equal to 3 upon 2. So that means this shows that these ratios are equal. Pn upon Nr is equal to Pm upon Mq, and therefore here we, from where we got it here, from first and second, we came from first and second, we got that these two ratios are equal. If the ratios are equal, then the lines are parallel, and which is the theorem saying that? Converse of basic proportional theorem. So therefore can I say that segment N, what is that? The NM is parallel to segment, NM is parallel to segment RQ, and you have to write it over here by converse of basic proportionality theorem. Reasons is very important to be written over here. So this is how what I finished with the basic proportionality theorem, converse of basic proportionality theorem, where I showed that the ratios are equal, then the lines are parallel, and basic this is converse of basic proportion theorem, and the basic proportion theorem is saying that the lines are parallel and the ratios are equal, and this is how I finish here question number 2nd. Yes. Students, I want to tell you something over there, that we have finished our algebra chapter. But do you know that algebra chapter which I taught you, it is not completed still. Why it is not completed? Because I have not taught you still the star mark sums, still the solid example sums, and but in the board examination one more question which comes over there, that related to your portion, but it is not from the textbooks. So see that there are so many things still has to be practiced over there. Star mark sums, solid example sums, and the sums which are not from your textbooks but related to your portion. Okay, so you have a lot of things to be practiced when you come to the classes, and we will be practicing that sums also. But before that, I want you people to, now you are in a lockdown mode over there, so you people sit and practice. Don't think that this time is to relax and enjoy, because this time will go, later on it will be burden on our head over there. So you all try to practice this sums, whatever I have given over there. You thoroughly practice, plus I'm started with the geometry also. There also you start practicing, because a lot of theorems and properties are there. So I want every day you sit and practice, and you can repeat your rewind the videos and check that over there if you don't understand. So you people do it thoroughly. So when you come back to the classes, I will be continuing further, not this stuff. Now whatever I thought, I will not teach you that back again. I'll be teaching you the further sums over there. So I want you people to thoroughly practice at home and come, so that I can carry on with my other